Now what we're going to be doing is solving formulas, or also literal equations. In other words, we're going to have more than one variable and we're going to be solving an equation for one of those variables. We'll follow the same steps as we did before. We'll take care of fractions by multiplying by the common denominator or cross multiplying. Take care of parentheses by distributing through them. Combine like terms. Move terms by using the additive property of equalities, where we add something to both sides or subtract something from both sides, so that we get our variables on one side and our constants, or the variable we're not solving for, on the other side. And then finally divide by the number beside the variable you're solving for. And you can memorize this in a lot of different ways. Some people put words to this like Fred passed the coffee, milk, and donuts, and that tells you to take care of fractions, parentheses, combine like terms, move terms, and then divide. And let's go ahead and do this here. This first equation here is a equation that's used in radiology, and we need to solve this for m. So here's the equation again that we need to solve for m. And what I would be doing is, there's no fractions and no parentheses and even no like terms to combine. So it's just a matter of moving terms to one side. So I have my positive 2m on the right hand side, which is what I need. I need to solve this for m. So this k, I'm going to need to subtract k from both sides. Subtracting k from k is out of there, and t minus k is just t minus k. So you can do it that way, or you can just think of when you move a term across the equal sign, it changes the sign. Either way you want to think about it. Same way here with the minus 10. We add 10 here, minus 10 plus 10 is out of there, and over here we'd have to add 10, t plus 10. So whether you think of moving them or adding the opposite to get rid of them, we'll end up with t minus k plus 10 equals 2m. And then divide through by 2 on both sides, so we'd have all this stuff divided by 2 is what m is equal to. Now you could write the answer this way, or we can break up a fraction. If we have a numerator over a common denominator right there, we could break it up and say, well, that's t over 2 minus f over 2 plus 10 over 2, which is 5. So either way, it will work. Here's some other examples that we'll do solving them, these literal equations for a variable. First problem, negative 2x minus 10y equals 5x plus 6, and we're supposed to solve it for x. So what I want to do first is any fractions, get rid of them, any parentheses, get rid of them. Well, I don't have any of that, and I don't even have any like terms, so it's just a matter of moving our terms to different sides. So I need to subtract 5x from both sides, or I could have added 2x to both sides. Either way would have worked. Here I subtracted the 5x from both sides, and I added the 10y to both sides. So that gave me all my x's on the left hand side, and combining those gives me minus 7x, and on the right hand side I have 6 plus 10y. Now I need to divide both sides by the minus 7, so that would give me 6 plus 10y over minus 7. Now there's a lot of ways you could write this. You could put this in standard form. Standard form is from the highest power on the variable down to the constant. So 6 plus 10y is the same as 10y plus 6 over a negative 7. We could also break it up into its parts and say that's 10y over a negative 7 plus 6 over a negative 7. And we don't have to keep the negative on the bottom. We could put the negative on the top. 10y over negative 7 is the same as negative 10y over 7. And this is the same as negative 6 sevenths right here. So all of these are correct answers. So let's do the next one here. Solve 3x plus 5y equals 6 for x. So I would just move the 5y to the right, or subtract 5y from both sides, and I get 3x equals 6 minus 5y. Now divide through by 3, and I get 6 minus 5y divided by 3. That's an answer. We could clean it up and say 6 over 3, 2 minus 5y over 3. So that would be also a way of writing this answer. And if you wanted to write the variable first, it would be minus 5y over 3 plus 2. Solving this equation, y equals negative 2x plus 3 for x, we could subtract the 3 to get y minus 3 equals negative 2x, then divide through by the negative 2. So again, we could have the negative on the top or the bottom, so we could have written this equation as y minus 3 over negative 2, or the negative of this, y minus 3 over 2, and we could distribute that negative through if we wanted to. Now, as I was saying, you could have distributed this negative through if you wanted to, and if you wanted to distribute the negative through, we would get negative y minus a minus 3, which is plus 3 over 2. And then we could have even broke this up into its component parts. We could have said this is x equals negative y over 2 plus 3 over 2. Okay? And if you wanted to write the constant first, you could. You could say this is 3 over 2 minus y over 2. So all of these are actually correct answers. And if it's a multiple choice test, then you just have to see which way the answer was written in. Here's another problem. Solve y equals the quantity x plus 3 over 2 for x. Now we could do this how we usually do, which is multiply by the common denominator, which is 2. So I put a 2 out here times this the whole equation, and that would give me 2y, and then take the 2 and the 2, it gives me 1. 1 times x plus 3 is x plus 3. So we get 2y equals x plus 3. Now just subtract the 3 and I get 2y minus 3 equals x. We could also solve this problem by thinking of it as a fraction here on this side, thinking of the y as being just y over 1. And now we could solve it by cross multiplying. And here we are with cross multiplying it. 2 times y is 2y, and 1 times the x plus 3 is x plus 3. Just subtract the 3 and we get 2y minus 3 equals x. So either way we get 2y minus 3 equals x. On this problem we only have one variable, so we should get a numerical answer to this problem, unlike the other ones on this video where when we solve it for another variable and there is 2 variables in the problem or more, you don't get a numerical answer, you get a new equation. So with this problem we should get a numerical answer, and we can solve it by multiplying by the common denominator, which would be all of this, 3x minus 4 and this, the quantity 2x minus 5. You can look at it that way, or we could cross multiply. If we cross multiply, we take the 2x minus 5 times the 5, and we take the 3x minus 4 times the minus 6. So that eliminates the fraction. So now just distribute the 5 through here. 5 times 2x is 10x. 5 times minus 5 is minus 25. Now distribute the minus 6 through the parentheses, and we get minus 18x, and a minus 6 times a minus 4 is plus 24. At this point I added 18x, or I moved the minus 18x to the left, and I got 10x plus 18x, and I moved the minus 25 to the right, or you could say I added 25 to both sides. So over here I'll have the 24 plus 25. 10x and 18x is 28x, 24 and 25 is 49. Finally divide both sides by the 28, and I get 49 28ths, which reduces down to 7/4, or 1 3/4, or 1.75, and you could check it by substituting it back in and see if it actually works. It isn't a bad idea to do that anytime you have a variable in the denominator, because if this number, when you substitute it back in, makes the denominator 0, then that would not be considered a solution to the problem, because division by 0 is undefined. But if we substitute 1.75 back in, or 1 3/4 back in, or 7/4, however you want to say it, back in, you won't get 0 in the denominator. So that is the right answer to this problem.